Thank you, Alyssa. Okay. Hello, I'm Jeff Cross, and I'm going to talk about mistakes that you make. I'll share these slides so you don't have to take pictures. The slide notes have links in them and everything. So I used to work at Google. I was on the Angular team. I led the mobile team on the Angular team. And so I thought a lot about mobile along the past couple years. And particularly mobile performance is the thing we were focusing on. But as of last December, Victor and I left Google and started our own company, Narwhal, where we help big teams do big things with Angular. And the same plugs Victor gave, you can check out our website and our blog. We blog a lot about Angular, really deep, interesting things with Angular. And we're also on Twitter. And we've got these books. And Victor can give you free codes for these books if you're here in person. Sorry if anyone watches this video. I don't know if you get the book for free. So I'm going to talk about top 5 performance mistakes of Angular mobile web apps. And these are real world things, like things I see all the time. Have seen a lot over the years, and different reasons why they happen, and it's a lot of times people just don't know, or things are too difficult to get right. I came up with the title when I was sick. Like, I had this really bad head cold, and I was driving to Tahoe with my crying kids, and there was like snow everywhere, and so it was a little bit negative. And so I want to make it a little bit more uplifting and talk about top 5 performance opportunities of Angular mobile web apps. Things you can do right more than things that are being done wrong. And I'm an engineer, and it's really hard for me to be disciplined, and I was going to try to make it like 5 things that I could go a little bit deep on, but there were more things I just wanted to add in there, and so it turned into being a lot more than 5 things. So I did group it into 5 categories, though. So the first category is loading, how you can load quickly, and most everything in here is based around loading. With mobile, that's the biggest thing. Like runtime performance, Minko talked about yesterday. There are a lot of things you can do with change detection, being careful about how you're rendering applications, and that's important on mobile too. But most of what I observe is loading-related issues. Analysis, measurement, the two kind of go hand in hand. HTTP2, and how you're fetching data. So let's dive into loading first. So pre-rendering. Has anyone here tried pre-rendering with Angular, either with the old universal stuff or with the new platform server? Okay. Was it easy? Anyone think it was easy? Minko did. Well, you're a show-off. So pre-rendering, if you don't know what pre-rendering is, it's basically you want to ship to the browser already rendered HTML with content in it, or at least some kind of content that the user can see that your app is starting to load as Angular bootstraps in the background. So this thing on the left, where we've got some content there, some text there, some layout, as opposed to the thing on the right, which is empty until Angular is done bootstrapping in the client. So the reason why we want to do pre-rendering is because we want to focus on, really when we're thinking about loading, there are 2 key metrics. There are more metrics you can think about, but there are 2 that really come up often, which are the time to first meaningful paint. In other words, when the user first sees something on the screen, it may not be all the content, but it's something where they can see either a shell of your application or something that says, okay, something's working, something's happening, they're getting the application ready for me. And then there's the time to interactive, which is when Angular is done bootstrapping and you can actually scroll around, click around, navigate inside of the Angular JavaScript application. With pre-rendering, we essentially take this cycle where at the top, without pre-rendering, we see that we load our HTML, we parse it, and then we load our JavaScript, we execute it, and eventually we see the fully rendered and interactive page. So without pre-rendering, we see both of those metrics happening at the same time because we see this loading thing, which is meaningless, and then we see the content and interactive because Angular's done bootstrapping at the very end. But what pre-rendering lets us do is short-circuit this by moving the pre-rendering of the content either to build time or to the server, which it can be done more quickly, presumably. We can, as soon as the HTML page is loaded, parsed, and rendered, we see content, even though Angular hasn't bootstrapped in the client yet. And so this moves this metric of the user seeing something happening much sooner in the life cycle, and the interactive stays at the same time it was before. Maybe a little later if you're spending a lot of time computing the pre-rendering at runtime. And now this used to be possible with a project called Universal that was managed by the community, but as of Angular 4.0, there's a module inside of Angular called Platform Server that enables this. And this is a pretty new thing. So this was, I can't remember when Angular 4 came out, 2 months ago, beginning of April, something like that. I'm looking at Victor and he's not helping me. Okay, yeah, 2 months ago-ish. So it came out, it's still relatively new. A few select people like Minko know how to use it. I know how to use it because I talked to the people who developed it. But it's not that easy or well documented right now, but myself a little bit and other people are working on building better tooling and better docs for it on Angular.io. I think there actually is something on Angular.io that says how to use it right now, but I think it is not supposed to be published yet. It's still a little bit rough around the edges, so you can look at it now, but I would say stay tuned. There's going to be more tooling for building, pre-rendering at build time with Webpack, using Express, other popular server libraries to do pre-rendering at runtime so you can more easily pre-render your applications. So another part of loading that people often neglect or don't understand is how they're loading their scripts in other assets, but mostly scripts. And this, even when you're pre-rendering something, this can affect the UI. This can really make your pre-rendering efforts useless if you don't get it right. And what I mean by script loading is, I mean when you put a script in the page, like script source, whatever, it's loading something over the network. It's going to load it, parse it, execute it, and then go in order. And it's somewhat blocking of the document being parsed because those scripts can have side effects on the document, so the document can't finish being parsed until those are all done. And a lot of browsers, Chrome's pretty smart about this. They've gotten smarter about handling this, and they can actually render stuff while scripts are still loading. But Safari, like WebKit Safari Mobile, is really strict about how you load scripts and how it will render your pages when you load scripts in different ways. And in this way, when you load scripts in your page where you just have script tags with sources, you'll usually see a white screen on Safari until your app is all downloaded and bootstrapped and done. So even if you pre-render your whole page, you'll probably see just a white screen until your scripts are all done loading. And so it's like if you're trying to pre-render to optimize for mobile, then you lose out on all the benefits. But there are a couple of things you can do to tell the browser that it can load your script asynchronously and defer the processing of it. The first attribute is one called defer. So if you just add this to your script tag, it will let the DOM parser finish. It will pass this, and as long as there's nothing else blocking, it'll finish parsing and then can paint the DOM. So whatever's parsed in your HTML right now can be painted and shown to the user. But one thing about this is it delays the DOM content loaded event, which in Safari, I think they paint at the same time they fire the DOM content loaded. The first paint is the same time. So even when you use defer, Safari still tends to block the rendering. I've done a lot of experimenting to see if there are different ways to use it and not block rendering, and haven't been able to do it. So in other browsers, this is a nice hint, like Firefox, I think will give you the right behavior. Chrome, this is a good hint to Chrome. One thing about defer that's nice is even though it'll pass the script and it'll start loading it, then pass it in the parsing and load other scripts, it will guarantee the execution of order of your scripts. So whatever order you've placed them in your DOM, it's going to execute them in that order, even if they happen to be loaded out of order. But there's this other helpful attribute you can add to your scripts called async. And unlike defer, like defer, it doesn't block DOM parsing, but it doesn't delay the DOM content loaded, and it doesn't have the guarantee of order of execution. So this is actually the most friendly to Safari, Safari on iOS and on desktop, that it will load your scripts and it'll let the DOM finish parsing, and then whenever it's done loading, it'll execute it and your app can bootstrap. So if you can use this, the downside is, since it doesn't guarantee order, you can't really have a bunch of script tags in order that depend on each other, like you would get by default out of Angular CLI or pretty much any other Webpack configuration where it's going to generate a bunch of scripts. Because if they load out of order, you're going to have errors of things not being there that they expect to be there, like polyfills. So if you want to do this, you'll have to either concatenate everything into a single script, or have a loader script that you can load that will then load everything else in order, so that you can take good advantage of caching the different modules. Like for example, you don't want to blow away your polyfills bundle cache every time you're updating your application, because that tends to outlive your app bundle a lot longer than the app bundle. So the third part of loading is inlining critical CSS. So going back to rendering, if you've got a style sheet in your head like this, this also blocks rendering of your page and parsing of your page, because well, maybe not parsing, but rendering at least, because when Angular sees the style sheet, it wants, or not, when your browser sees a style sheet, it wants to make sure that it's not rendering content without the styles already present. So when it sees this, it will load the style sheet, wait until that's done loading, and then if the DOM's all done parsing, it can render the page. And so if you've got a big global style sheet like this that has a bunch of styles that maybe don't even apply to the front view, then you may be needlessly loading things that you don't need to. And anytime you have anything network bound, like requesting a style sheet that's blocking rendering, it's good to avoid any network bound operations like that from blocking rendering if you can. Even if it is a small style sheet, you would like to inline that. So what you can do, you could manually inline styles that you would want to, that you know are needed for your app shell or for your main screen view into your home, but that's a little bit tedious and not very sustainable. And then you could preload the rest, where you could say, okay, I'll inline the bits that I need, and then I could use this new browser hint called link rel preload to load the rest, which here you can see I'm just using preload. This tells the browser, start loading this thing, but don't block on it. And then when it's loaded, I'm setting this link element to a rel style sheet so that the browser will know what to do with it. But doing this manually is a little bit tedious. So fortunately, there's a tool called Critical that Adi Osmani made at Google that makes it easy to analyze your home screen and to inline the CSS that's necessary for that view, and then to preload the rest of it so it can load asynchronously and be ready for the rest of the views in your application. And it's on NPM, and we also have a Webpack plugin that we made around Critical that lets you add this to your Webpack build and take the home screen of your application, inline the CSS that's needed there, and not block the rendering of it. But one thing to know about this is you can't just throw it at any Angular application and get benefits from it. There needs to be some kind of pre-rendering happening in your, like either an app shell where you just have the basic parts of your UI present, or something that actually would have styles applied, or else Critical is going to see an empty document and say, well, I really just need to bring in the body styles because there's nothing else here. And so then you won't get the benefit of Critical inlining. So app shell plus Critical is a really good combination, or any kind of pre-rendering in Critical, so you can only inline the CSS you need and not the rest. AOT. We've talked a lot about AOT this week. I think it's kind of an easy one. It's ahead of time compilation. Hopefully everyone knows by now that it's a good thing to do. It's pretty easy to do now, a lot easier than it was a year ago, at least. One important note, this is different from pre-rendering. So AOT is ahead of time compilation, not pre-rendering. The goal of AOT is to generate faster JavaScript, whereas pre-rendering generates HTML pages. So you use both. You use pre-rendering, and then you're loading AOT compiled scripts. And the way AOT makes apps bootstrap faster is because it's shipping smaller bundles and it's doing less work at runtime. So the bundle doesn't include the compiler or other parts of Angular that you would need if you're doing just-in-time compilation in the browser. And because the compilation is happening at build time, you don't have to do it in the browser. So you get significantly faster bootstrap times, typically 50% less time to bootstrap in the browser from what I've seen. So with Angular CLI, thanks to Mike Brocky, if you build with prod, you get this by default, and it'll be nice and small and fast for you. I think that's only a couple months ago that this was the case, right? It was possible to do with the AOT flag before, but prod was default to AOT 6 months ago. Oh, time flies. So with CLI you can do it, and it's nice and easy, but the same tool that CLI is using in Webpack to make it possible is available at ngtools/webpack, and you just throw this plugin into your CLI configuration, give it a little bit of configuration, and it'll handle the AOT for you and give you some other nice conveniences like lazy loading. I wrote an article about 6 months ago about AOT on our blog, and I've got a link in the notes here you can look at, where I talk a little bit about why it's beneficial, and I do some performance comparisons of before and after AOT to show how drastic the change is. And lastly in loading is lazy loading. So lazy loading is basically just include the code that's necessary for the first screen in your main bundle. So all your other components, modules, whatever in your application that aren't necessary to serve that first view when the user's hitting your home page, get that out of the bundle and load it only when the user needs it, so that the bundle can be smaller, faster, all that good stuff. Now, Angular and Angular CLI make it really easy to load these secondary routes, thanks to Victor. I just do things to make him uncomfortable. So it's easy. You just use this load children property of your route config. So like for an admin, for example, you're not going to want to load this for every user that comes to your site. You just give it a load children instead of giving it a component, and it'll defer to this module to handle routing to that. And when the user navigates here, assuming you use the ngTools Webpack or using the Angular CLI, it will go ahead and separate this module into a separate bundle, a separate chunk that will be loaded when the user requests it. There are also optimizations that you can use to preload modules. Like, so after the app's bootstrapped and the user's using it, it can, in the background, start loading the other modules that the user might need, so that when they do navigate to them, it's already in memory. It's pretty fast to open the new route. So there's a nice guide on Angular.io that talks about how to do lazy loading. And Victor has written a book about Angular Router that goes into some detail about this, and a lot of detail about the router. You can bug him to get a code to get a free copy of that too. So to summarize lazy loading, or the loading part, and this will be the most, everything else will be easier than the loading part, I promise. But you want to pre-render something, at least a shell. You want to use script async in some way. Inline Critical CSS, use AOT, and load only immediately needed routes. So our second opportunity is analysis. So one thing that I think a lot of teams don't do a good job of is really having someone who's owning performance. Everyone focuses on features. All the planning of iterations is based on features, and a lot of times everyone works on things and you check that it works and you ship it, and nobody's really looking at what's happening or what the overall user experience is, how fast things are, until somebody gets really frustrated with your application and calls you, or your boss comes in and tells you that it's terrible when it's already in production. There are a lot of things that teams can develop as habits for each developer on the team to do to kind of make sure that performance doesn't get bad or that you don't get into too much debt. And one is just using dev tools. And dev tools, like Chrome dev tools, are obviously the best. All the browsers have dev tools, but Chrome has really been leading in that regard, especially with performance. There's a lot to it, and I think in a lot of cases that can be intimidating. So people know you can do all this crazy profiling and timelining and weird graphs and call trees and things that you may not know. But I think if you just look a little bit, don't overthink it, don't be too intimidated. There's a lot you can just load your network tab, for example, and see what's happening to see how you can improve your application. So even just opening your network tab, looking at what's being loaded at startup, and figuring out what things are in there that you may not need for the startup, like whatever marketing scripts or things people are jamming in there that are blocking your rendering. Look at it, reduce it, repeat it. Nothing new. Like looking at this Hacker News app, they do a pretty good job. So you can kind of see, okay, things are loading in an expected order. So that's kind of a given one, but a thing a lot of teams just don't have as part of their habits or part of their process to be doing. But a tool that, has anyone here used Source Map Explorer? Minko, you can just keep your hand down for. All right, cool. So this is one of my favorite tools, and there are other variations of it, like Webpack Bundle Analyzer. Mike, you might like Webpack Bundle Analyzer. You do? I don't. I like Source Map Explorer better. But what this does is when you generate your bundles with source maps, with whatever tool you're using to generate bundles, you can use Source Map Explorer to see what's inside your bundles. So it arranges it in this really nice to look at way, and you can see, oh, this module or this package wasn't supposed to be there, or this package is taking up a lot more space than I thought it was. Maybe I should get rid of it. It's pretty easy to use. We'll skip over the how-to, but basically you install it and you use it. You point it at a map, and it gives you this view like this, which was kind of hard to see on the screen, but it arranges boxes of different packages that you're including in your bundle, and it shows them relative to the size they take up in your bundle. So you can see, whoa, this takes up a lot of space. Do I need it here? Is it supposed to be there? Like a lot of times people will accidentally import all of RxJS, all of its operators, even though they're not using all the operators. So using something like Source Map Explorer gives you insight into what's being included that shouldn't be. There are other tools like Webpack Bundle Analyzer, but this is still my favorite. Another one that, has anyone used webpagetest.org? Okay, cool. So this is an awesome site. It's so ugly, but you get tons of data out of it. You basically, and it's sponsored by a bunch of companies. Google sponsors it. Google helps contribute to it, and Google uses some version of it internally as well. It lets you analyze your real-world performance of your sites on real devices for free. You basically just give it a URL, give it some configuration, and say run it, and they'll run your app like on a mobile phone or in different browsers on different computers, and give you lots of characteristics about it. So you just go here, this website. Like in this case, I told it to emulate 3G connection, run it 3 times, and do it on a Galaxy S7. And then it gives me these reports of things that are good, tells me the total time to load, time to paint, and that kind of thing, and lots of different analyses that I can drill down into. So it'll give me screenshots as the page is loading to see what it looks like at 1 second, 2 seconds, and so forth. And then it'll give me more performance review of recommendations that it has to improve the application, things that aren't what they would be expected to be. And it will give me a network waterfall analysis similar to what I would see in DevTools, so I can see how it's actually working on a real device. So to summarize analysis, measure network performance, analyze your bundles, and test in real-world conditions. Now, measurement. Another thing that I have noticed is not part of team habits a lot of times is defining goals for performance. You may define it in things like how many watchers you want to have or something like that, a singular one, because watchers was such a big issue. But a lot of teams don't define things like how quickly they want apps to load or for meaningful paint on mobile, even though most teams would say that mobile is important for them. So one thing I would suggest is to start by establishing sometimes, even if first meaningful paint and time to interactive aren't the important metrics to you, figure out what devices under what conditions are we targeting and what are our goals for that. And if you want a good place to start, Google has this set of guidelines called Rail, and I've got the link in my slides. And they have great documentation based on research of how users engage or disengage with content based on latency and responsiveness, and lots of good data. And they have, there's a quote there that says, load your site in under 1 second, or user attention wanders and their perception of dealing with the task is broken. So the user feels something's not going right if it takes over a second. And if you're targeting 3G, 1 second is not very easy on the first load at least, but it is possible with a lot of tuning. So it's a good goal to have, even if it's somewhat unachievable. But to measure your application, there are some good tools once you've established the guidelines you have to help you check that you're in line with those and to enforce it, which are Lighthouse and a tool that goes along with it called PW metrics. So Lighthouse, has anyone here besides Minko used Lighthouse? Okay, or you two, or any GDEs can keep their hands down. So Lighthouse is this tool that the Chrome team has put out so progressive web apps, does anyone not know what progressive web apps is? It's this thing Google came up with this way of describing web apps that behave like native installed applications, and it's all under this umbrella of progressive web apps. And so there's some technical aspects to progressive web apps, like a checklist of things you can say that are the baseline of a progressive web app, which are that it should work offline, it should have some kind of pre-rendered or app shell experience, and it should have a service worker, which goes along with offline, and it should be installable to your home screen on platforms that support that. And so they made this tool called Lighthouse, which actually scores your application on a scale of 100 to see how much it satisfies the requirements of PWA, both the technical parts of it and the performance expectations of PWA. And it's a Chrome extension as well as a CLI tool. It's on GitHub. I've got a link here where you can go to it, but it's an NPM package that you can install and run locally against your projects, and it'll give you a score and a nicely formatted page that tells you different areas where you can improve to hit better performance marks and better user experience. It's cool. It uses Chrome's built-in emulation of 3G and low-powered CPU, so you can test in similar mobile, close to mobile real-world environments, even though it's emulated, and see how well your app does on 3G. You can also disable that, but it's nice to see what it comes up with. And they give you this nicely formatted report. So that's good for development time. You can see if you're hitting your targets and look at the report it comes up with to see how it looks. But there's another tool called PW Metrics, and this is something Paul Irish from Chrome has put together. That's a CI tool built on top of Lighthouse, so you can actually put expectations around the metrics, and you can either warn or fail your build based on not meeting those expectations. So you can have as part of your CI process a script that runs after you build your app. You can run PW Metrics, install it like this, and you give it this file that tells the metrics you care about, like time to first meaningful paint and time to interactive, and you can say warn if it's above 2,000 or fail if it's above 3,000, so that you can catch regressions before they get committed. Some other cool things is you can upload it to Google Sheets, so you should run it in your continuous integration environment. So to summarize measurement, you want to define targets, you want to know what you're shooting for, you want to set bundle budgets with Webpack, which I didn't talk about much, but you want to set budgets and targets for things, and then you want to fail your builds on performance misses. So step 4 of 5, we're almost done. HTTP 2. Has anyone used HTTP 2? Anyone not know what HTTP 2, not used it, not care about it, or Uri doesn't care about it? HTTP 2 is this, I really like HTTP 2 because you don't really have to do anything. You just enable it. Like most servers, it's just a configuration that you build with Nginx. You just build it with configuration. Most infrastructure as a service has some support for HTTP 2. But it's a new standard for HTTP communication. It does lots of things, but the key benefit of it that web developers benefit from is that requests are really cheap and low latency. It does this by sharing connections. So if you connect to a domain or an origin, it will share that connection for every request in that session, as well as any other tab or window that's connected to that origin will share a single connection. So you're not having to renegotiate and do extra round trips every time you want to request another resource from that origin. And there are some other things it does, like it does good header compression. It will not send data if data hasn't changed for a header. It'll just key it. And so requests and responses become a lot cheaper. And if you enable it and you're using it, it falls back gracefully if the browser that's connected to your server doesn't support HTTP 2. Like some old mobile browsers or old desktop browsers who don't have HTTP 2 support, they'll still work. They'll fall back to HTTP 1.1. You don't know any different. You don't really do anything different. And most servers and CDNs now have support for it. So the key here is that you should just use it. There's no real downside to using it. It'll just work. But one interesting feature about HTTP 2, which some teams have used, some have overused, is server push. So basically, your server, when it gets a request, it can proactively push resources that it knows will immediately be needed without the browser requesting it first. Like a good example is if you've got a lazy loaded route. If I'm receiving a request on the server to a deep link in my site, and I know that this link is going to require some other chunk to be pushed, I can go ahead and push it before the browser has even asked for it. And then by the time the browser makes the request for it, it's already in memory and is loaded really quickly. But some caveats about this is that it should be used with caution. You should only push what's definitely needed immediately, or else the browser it'll log something in the console saying, hey, you pushed something that you didn't need, and it may throttle you later. It might penalize you later and not let you push stuff or abuse the cache or abuse the server push. And you don't want to push what's already cached. So if something's already in HTTP cache, like if the bundle's already been downloaded before and you're pushing it, then you're just pushing bytes down that don't need to be pushed down and wasting the user's bandwidth, which on mobile, it's like data costs money sometimes, and it also drains battery if you're using that network a lot. So to summarize, use HTTP 2 and come up with a good strategy for push and use it intelligently. Better not to use it at all if you're not going to be really thoughtful about how to use it. And opportunity number 5, data fetching. One thing I see a lot of is request chaining. There's probably a better way to say this, but making dependent requests that are blocking getting data to the view that are subsequent requests one after another. When loading data, it's important to get the above the fold content in a single request. And a lot of teams have standardized on this as a requirement where they actually have tests making sure that when you're navigating to a new view or loading the homepage that you're getting the data payload in a single AJAX request. For example, if I'm getting a user from a service and I want to also load the preferences for something, I might say my service get user, and then once it's loaded, I'll switch map it into another call to my service that says get user prefs. And at the end, I'll return some meta object that has the user profile and the preferences, and then it gets emitted to the view, and Angular can render it and show components. So I'm having to wait for subsequent HTTP calls to finish before I actually emit a value for my view to do anything with, when really I could have probably just rendered the profile before having the preferences ready, and then render the preferences when the preferences are ready. And this is pretty easy to do properly in Angular if you just have a separate observable. So because observables compose so well, because Ben Lesh is such a genius, actually Eric Myers, but Ben learned from the best. Since observables compose so well, I can actually just bind this user profile observable to my view, and as soon as that comes back, in my component, I can unwrap it with async and render it right away. And then I can add this other observable, the user prefs observable, just chained onto that observable. And whenever the user profile observable emits, I can say, okay, I've got the user, now I'm going to make another request to prefs to get the prefs, and I bind to that separately in my view, and that view will update itself when that comes through. Ideally, you could look at the trade-offs of maybe you have this all in a single request to your server if you want to change your API to return this whole payload. But then you obviously have a larger payload to send back to the client, and you really have to weigh these things to say, okay, is it worth having a larger single request or a deferred second request where I can just load the important object first and then load the second object. So the next thing, something in the same vein, is route resolvers. If you've got route resolvers where you're doing the same kind of data loading and you're blocking the resolution of your route until all the data is present, it's probably going to make for a worse user experience. You're waiting for multiple requests to resolve before you're showing any content. So route resolvers should only have the critical content for the view you're trying to render. And another good way of thinking about it is only put the content that you need for search engines to see your page as route resolvers, which I think is a pretty good practice to wait to resolve routes until you've got the data that you'd want a search engine to see. And that's usually a good heuristic for what is above the fold and important content for a user too. So to summarize data fetching, you want to get critical data in a single request, and then you want to resolve routes only for critical data when they're ready. And with that, I am done talking about mobile performance. Thank you.